Okay, hello everyone. Now we'll continue with the nature of functions. Here we look at how to pass an array as function parameters. Okay, so we can also pass array to a function. Look at this example. Here we have void my function int my number 5. Of course, if you're in my class, um, this is how you write an array. Okay, that's how you declare an array. So you have my number 5. The 5 there tells you the size of the array. That means the number of elements in the array. So then this is my definition. Okay, this int I equal to 0, I less than 5, I plus 2. If you're in class, you know that this means that I start with 0 and end with 4. Okay, so see out my number I, that means 0 to 4. Okay, so that's the definition for I. So you have my number 0, that's the first, and that's the first position. And you have the int main, which is the call function call. Okay, says int my number 5, then equal to 10, 20, 30, 40, 15. Okay, and so my function numbers will be, let's try this, let's run this. Okay, so you can see that. So my function numbers, when you put the parameter in my function, is going to show you 10, 20, 30, 40, 50. Okay, because that is what my number is based on the question. Okay, so we go back. Now let's explain the examples. It says the function, my function, takes an array as its parameter, as int my numbers 5, and loops through the array elements with the for loop. Of course, the for loop loops through the elements. When the function is called inside main, we pass along the my numbers array, which outputs the array elements. Okay, note that when you call the function, you only need to use the name of the array when passing it as an argument. That's what we have there, my function, my numbers. However, the full declaration of the array is needed in the function parameters, which is int my number 5. Okay, now that's important to note. So there are two ways I would have written this. I could still have written this up here. Okay, I could still have written this up, but that's fine. It's still the same thing. It still represents. Okay, so let's move to. Here we have what we call function overloading. So what is function overloading? The function overloading, multiple function can have the same name with different parameters. Okay, so look at, like we have here, you can see int my function int x, you see that? Float my function float x, double my function double y. Okay, consider the following examples which has two functions that add numbers to different types. Okay, so let's see. We have the it has int plus function. Don't forget that the int here means that you're expecting to return a value. So plus function int x, int y. We ask to return x plus y. Then you now have double plus function, double x, double y. We also ask to return x plus y. Then we have int main. Okay, this is now to call the function int main. Then you have int my num1 and the plus function int 85. You see that? Okay. Then you have double my num1 equal to plus function double 4.3 6.28. For the 85, that of the int will run. For this, that of the double will run. Then see how this is what we are printing out, which is int my num1, which we add that of the that of the int. Then y here we add that of the double. So let's run this and see. So that is it. You can see int 13 and double. Int 13 and double 10.56. Okay, that is important. So this is possible. That's what we call overloaded function. And instead of defining two functions that should do the same thing, it is better to overload one. Okay. In the example below, we overload the plus function to work for both int and double. Oh, this is beautiful. So let's look at this. So we have int plus function int x, int y. Okay, then return this. Then we have double plus function double x, double y, then return x plus y. So int main, we have int my num1. Okay, this is just what we did. This is just what we did earlier. Okay, there is no difference to what we did. So you note multiple functions can have the same name as long as the number and or type of parameters are different. Okay, so they can have the same name as long as the number and the type of parameters are different. I think that's the important thing to note here on this overloaded function. Okay, so let's see. The next is, which I think is the last for functions, is recursion, C++ recursion. Now look at the definition. Recursion is the technique of making a function call itself. Okay, this technique provides a way to break complicated problems down into simple problems which are easier solved. Okay, recursions may be a bit difficult to understand. The best way to figure it out how it works is to experiment with it. Yes, I get that. So let's see these examples. It says adding two numbers together is easy to do, but adding a range of numbers is more complicated. In the following example, recursion is used to add a range of numbers together by breaking it down into simpler tasks of adding two numbers. Okay. Now, this is a very quite interesting case. So let me try to see how I can explain that. So here we already have int sum int k, okay, which is a function that wants to sum the element in k. And now you are seeing this, if k is greater than 0, we're asked to return this. Now this is an example of a recursive function. Okay, that's an example. So we are to return k plus some k, and I'm going to explain how that works. Okay, then here we call it in some 10, see out result. Now, amazingly, this particular code is going to add all elements from 0 to 10. Okay, and I'm going to explain why that is. So let's run this first of all. You see the answer it gives us is 55. Now this is how it works. This is how it works. When you say k plus some k, now k minus 1, okay? If k is 1, it means that this will be sum 1 minus 1, which is 1 plus sum, sorry, that should be sum 1 plus sum 0. Okay, and you can see that some int k is actually k plus sum. So that means sum 0 will be 0 plus sum 0 minus 1. Okay, which does not exist, so you have just 0. Then when you continue with k equal to 2, okay, or let me rub this off first. Let's do this again. You have sum 10, okay? 10, let's start with 10, sorry. So you're going to have 10. The formal explanation was wrong, please. So if I substitute 10, I will have 10 plus sum 10 minus 1, which is 9. Sum. Then what is sum 9? It means 9 plus sum 9 minus 1, which is 8. Then it will now be 10 plus 9 plus sum 8 means what? 8 plus sum 7, 8 minus 1, which is 7. And it keeps going, you see. At the end of the day, it's going to lead us to adding all the numbers. And this is quite interesting. So let's see the explanation the notes give. So this is it exactly. So when the sum function is called, it adds parameter k to the sum of the numbers. That's the explanation here, you see. When you put 10, remember the formula is k plus sum k minus 1. So if I put 10, it will be 10 plus sum 10 minus 1, which is sum 9. That same sum 9 means 9 plus sum 8. The same sum 8 means it keeps going until you get to this. You see that? Which means summing all the numbers. Oh, that's recursive function. It keeps going. We even use that in things like factorial. I think in your handouts, there is one that has to do with factorial. Factorial is, if I can remember very well, I think it was supposed to be n, then star. They now have maybe factorial. You can use the word factorial n minus 1. You can check your notes. When you do this, it means you are going to be multiplying factorial. Like for example, if I put 5 for n, it's going to be 5 times factorial 5 minus 1, factorial 5 minus 1, which is 4. Then factorial 4 also means, so this will be 4 times, will that have factorial n minus 1, 4 minus 1, which is 3. You keep doing that until you end up having 5 times 4 times 3 times 2 times 1 and so on. Okay, we also apply this recursion in this series called Fibonacci series. I'm trying to remember that, or Fibonacci series, which adds a number to itself. Okay, now the developer should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, yes, or one that uses excessive amount of memory or precursive precaution power. Now, please notice how did we terminate this function? It's stated clearly here. If k is greater than 0, then you can do this. So the k greater than 0 terminates, so that once it gets to 1, the function terminates, right? Okay, that is quite important to note. Okay, so we come to the end of function. In my next video, I will be doing further of classes. That's OOP, Object Oriented Programming. Thank you.